is Mark, who has put a lot of time into the software side of IoTuz. So he's going to give you an overview of the software development process involved in it. So thank you, Mark.
No problem. Thank you. So yeah, my name's Mark Wolfe. I work typically day to day. I work as a developer. So I've been probably a developer for about 15 years. Originally started in web stuff, did a lot of back-end database stuff. I haven't got a lot of experience with embedded development. So maybe 3 or 4 years ago, I actually started getting involved in a local hackerspace and learning about hardware. And then I actually did a bit of a spate at an IoT startup, but I wasn't involved in the actual hardware side. So when I left that startup maybe a couple of years ago, I actually decided that I really wanted to get involved in hardware, try and learn some of how those things underneath the software layers I've worked on actually function. So that's why, well, basically the reason I'm here. I don't do it as a day job or anything like that. I typically write in higher level languages like Python, Ruby, Golang, a few other Java, JavaScript. So this is every year. This is quite an interesting exercise. I work on a few other side projects which use C and C++. Most people, when I talk to them about what I do in my spare time, they're like, wow, that sounds pretty crazy. These languages aren't really that much harder than things like JavaScript or Java and stuff like that. They're certainly a lot quirkier, especially C++. But Arduino and the like has really made a lot of these environments much, much easier to get started with. And just a shout out to, like, ESPIDF has made this platform probably one of the most approachable embedded platforms I've worked on. Sort of basically with the Arduino environment and the ESP-IDF project, there's a lot of good documentation around them. It's mainly code documentation. So if you drop into the main page, which I'm going to go on to in a minute, and you feel a bit lost, basically have a bit of a look inside the repos. There's a lot of excellent code documentation in those repos. And there's a lot of, if you just search for some of the terminology, maybe the header files or some of the library names, you find a lot of really good information. And that's really what kickstarted this particular project source code and stuff like that. So always encourage you to do that. As Angus has said, the ESP32 is built on FreeRTOS. So there are a few interesting projects around FreeRTOS. The way I got started with it is basically I got a prototype board, started messing around with Arduino a little bit. Unfortunately, the Arduino didn't have support for Wi-Fi and a few of the other pieces of software. So what I did was I simply went, well, FreeRTOS, heaps of people use it. So what I'm going to do is I'm just going to grab a few of the header files out of the source code and do a bit of a search around. And most of my familiarity and my getting started were just around those particular examples, just getting started. So if you are digging into the ESP32 environment, most people, I'm guessing, will gravitate towards the Arduino environment. I would encourage you to try and step outside of that a little bit and try the IDF environment. I found it, once you started to get a bit more familiar with it, you could effectively interchangeably move code between the two environments. And for me, the IDF environment is a lot more, it just feels a lot more open to extension. So as everyone's pointed out, the ESP32 is a very, very new platform. The 1.0 version of the SDK came out while I was overseas in like the start of December. I got a dev board about a week or two after that and started mixing around, thanks to Angus again for lending me a dev board. Then we got the prototype, we had a bit of a hack around on it, still quite lost as far as where to start, etc., etc. But luckily, GitHub helped me with some of the starting points. A lot of the engineering is in the open. So one of the areas that I've used a lot doing the software development is basically tickets. there's a lot of people interested in this hardware. The ESP-8266 was a super successful project from a hacker point of view. Have a look at the tickets in the GitHub projects around this. There's a lot of tidbits, like I would get a bug or a problem, I would go, do a bit of a search for a ticket, bam, there's already 3 or 4 people talking about the problem. There's a couple of examples, how to work around it. So again, this is really unusual for a hardware project. Being able to see that history and conversation around problems is very valuable. And again, it's got an Arduino SDK. When I started, things like Wi-Fi, lightweight IP, and a few other things were still a bit of a work in progress. I haven't used the Wi-Fi features of the Arduino environment. I'll have a bit of chat why in a minute, but it is very, very good for prototyping. So very, very handy tools. So one of the things I did want to have a talk about was, we all talk about, effectively some stuff happens with hardware, then we start building software and everything's great. There's a lot of work that goes into a hardware project. Even just providing myself and Andy with prototype boards is always a challenge because you've effectively got a growing list of modifications that are going on around the software. Also, if anyone has ever worked on a hardware project or looks to work on a hardware project, there's effectively a prototype board, and then the board is totally changing in parallel to that prototype board. People are working on fixes for the next manufacturing run. In our case, we had a super compressed timeline, as Bob has highlighted. So that is even more important. So if you're ever working on a hardware project, whether it's a community project or anything like that, understand that whilst the board is being developed, you really do need to help people with some of the examples, help try and test whatever you can on the prototype board. Like we tested quite a few things on the prototype board. It didn't all entirely work, but we were able to provide some good feedback. So if you're ever working on a hardware project and you think that software development starts at the end of the hardware run, that's not the case. It needs to start all the way at the beginning. When people are wiring things up and trying things on a breadboard, when the first production run of boards comes out, when we get prototype boards, all of those phases really do need help from developers. It is super important. And in our case, this was a little bit, this was further exacerbated by the fact that the vendors, they've only just released the chip. They've sold out pretty much instantly. And they're still building a lot of these. There's so many peripherals in this chip. A lot of it is in a state of flux. That was, in a lot of cases, quite challenging for us because things are moving around us. You tell someone to clone a repo, it's already well and truly ahead of what you started with. So we had to basically freeze things up a little bit, make sure we tell each other what commit we're on, what are we using. Overall, very, very valuable because likewise, issues would come in, you've got fixes for them in the next couple of days just because it's moving so fast. Whereas I've worked with hardware developers or hardware vendors before, even with brand new hardware, effectively there'll be a 1.0 drop at which will maybe 80% work, and then there's crickets after that. And then 3 months later, there's another totally new software drop, everything's changed, and you're just supposed to sort of try and fill in the gap between those two. So this project is really unique in that you can effectively follow along with that. It's very, very handy. So the other thing that we tried to do, especially if you've got a very, very rapidly moving hardware platform, is try and just focus on the pieces that work. Try and test them out. Try and get something running on the board. In our case, it was just a matter of hassling people, getting something to power up, working with the components that we had. And as Bob's highlighted, there's a few test fragments in the actual hardware repo. I actually have a few other Arduino fragments that I'll contribute and throw into that repo as well. These are mainly things like, rather than spinning up the entire project, what I tried to do initially was just use some of the peripherals a little bit, maybe add a little bit more extra code to them just to sort of get a bit of a feel for that component and the IDF, or that component and Arduino on this platform. If you try and bring in too much hardware at one time, effectively you've got problems all over the place. It's very, very difficult to debug. So my normal modus operandi with this sort of project is, again, think positive, try and find somewhere to work, and while you're working, try and reduce the number of variables. It's very, very important in a hardware project, especially when you've never used the hardware before, you're only just new to the operating system, and the language is not your first language. Definitely try and zero in on those things. And even if, and this is what's happened quite a bit, is if I have a piece of code that's just an example, I can at least sit down with Angus or someone else and say, look, I really need to merge this in. What do I need to put around it? What do I need to change in it to make this work effectively in the environment? And if you're talking about an example that already works in situ, it's very, very easy to collaborate around that example. Whereas if it's a big group of code, it's very, very difficult for them to zero in on what you want help with. And the other thing that I have tried to do, although again, quite a compressed timeline, is try and drill into how some of the peripherals work. Again, cannot be said how good it is having such an extensive code base behind the project, readily available in your editor. I frequently click through header files into code, have a bit of a look around, and clarify exactly what I want to get out of this. And in a lot of cases, if you do a bit of a search and replace on GitHub, you might even find code that already works for that particular peripheral. So lots and lots of helpful stuff around that. So as far as the Arduino side goes, where are we? For those of you who haven't had a look at it, where is it? I had it around here somewhere. So there's quite a few examples. Effectively, the Arduino project is a little bit unusual from a point of view of when we're talking about the ESP environment, they give you a guide to setting up the Arduino environment. Now, the Arduino environment has an enormous amount of examples out there to do with a whole raft of different peripherals. We've got a bunch of those peripherals on our board. We had effectively two choices. One was to effectively write pure C versions of all of these libraries for all the peripherals, or plan B, which was more to my liking, was effectively use some of the Arduino libraries and just twist them, change them a little bit to accommodate the environment. Main reason there is we really want to get value out of it quite quickly. We want to see the peripherals working, and we also wanted to take advantage and help develop those particular projects and the capabilities they have, rather than reinventing the wheel for everything. So when we were having a bit of a chat, myself and Andy, about how can we use IDF, which is really, really good core, and at that stage was the only way you could actually get Wi-Fi, IP, a whole bunch of other things working, as well as Arduino. We noticed on this README that there's a section down the bottom saying using as an ESP-IDF component. So what that meant we could do, and if I scroll down, is effectively we can use the more advanced, more fully featured ESP-IDF environment to actually build an Arduino project. Now, I come from a software development background. I'm not a big fan of the Arduino IDE. I'm a big fan of the project. I'm a big fan of the boards and all that sort of stuff. But the Arduino IDE just kills me sometimes. So what I really wanted, all I really wanted to do was, just like in Linux, go into a folder, clone some stuff, and build it, just using make. No editors, no nothing. I just want to build it. And the benefit of this project is it allows you to effectively put your Arduino application into an IDF project and then just clone it, check out the sub-modules, and then just build the project, which is very, very handy. So really the advantages that we got out of it was we could effectively, for attendees here, show some of the code around concurrent tasks, multiple threading or multiple tasks within an Arduino project. And we effectively got to mix and match. So if we had a library that only worked on the ESP32, we could include that in the IDF project. If we had an Arduino library and we didn't want to reinvent the wheel, we could also include that into the project. So it's a very, very interesting feature. A lot of the times I talk to people about hardware development, especially around Arduino, is the real challenge with Arduino is it sort of stops at the prototyping phase for most people. This is really, really great because it effectively gives you a transition point to an actual full-blown C-based application whilst you're still taking advantage of all the amazing code and projects around Arduino. As far as getting started, what I did was messed around with the Arduino IDE a bit, and then I started messing around with this. And if you've ever done if you've ever built anything partially broken in a Linux environment, this is actually pretty easy to set up. Just create a makefile, set a couple of environment variables, lay out the code and the project structure as they say, and you can pretty much just start writing Arduino code, but just building it with Make. So very, very good. Super happy with that. So, and just if I scroll down a little bit, where are we? You can see here, initially, it looks like a fairly basic Arduino application. And then just after it, we have something that's starting to move towards an ESP-IDF project. Very, very handy setup. So we use that to effectively gain the ability to use both environments at the same time. Initially, it was a bit of a balancing act, but it's actually improving a lot faster now. So initially, the Arduino environment was sort of a bit ahead of the IDF environment as far as higher level drivers for some of the components. But now everything's sort of started to catch up on the ESP-IDF front. So effectively, the projects are more or are converging, if you know what I mean. A lot of the underlying code for the Arduino environment is using ESP-IDF. So very, very cool. Also, very handy. The ESP-Dev board is effectively my go-to test board. They are pretty hard to get at the moment. I was lucky enough to score one as a lend from Angus, but very, very helpful little board. It's very much similar to the ESP form factor board. Pop it on a breadboard, test some stuff. Very, very handy. Again, if you're working with an IoTuz or you're working in any hardware project, it just comes back to that. Come back to something simple. Just connect a couple of peripherals, get the code right, move it to the board. Helps a lot, especially when you're getting started. So the IDF environment is very, very similar. So from our sort of perspective, basically this is the project that we've used to build the code. As you can see, we've linked in the ESP-IDF as a submodule. What I would recommend is if you go to the examples in the Arduino project, have a bit of a mess around, pull this down. It does look a little bit more complicated, but certainly anyone I've actually explained it to and run them through, it's not too bad. I'm going to be around all week, so if anyone has any questions around it or anything like that, or wants to get a bit of a guided tour, more than happy to help out. Andy's also quite across it, and Angus. So if you really want to dig into it, I've added a couple of tickets as well, just around things that I'd like to see people help out with. So that's really about it there. So again, just drilling in a bit more around the hardware side. So really when I'm working on a software project for something like this, what I try and do is help the hardware people. In our case, because we had such a short timeline, we probably dropped the ball a little bit on this. We should have been in there helping Bob with the BOM, helping Bob with the layout. Now, initially, that's not going to be us doing the layout. It's more just checking the names of things matter, maybe helping out with documentation, checking and having just RTFMing a bit on the hardware, the peripherals, why are they wired up like that, what connectors are there. It's not about the actual layout of the board. You know, a lot of crazy stuff happens on a board. If anything, what we should have been trying to do is trying to help learn a bit more, do a bit more homework before we got the boards. And likewise, with a hardware project, because effectively you've got two very complex and different disciplines effectively colliding in the middle of a project, you need to understand that there are definitely the time ranges around hardware projects are much, much longer than software projects. It is often the case that the software gets compressed in the end. All the software developers get angry at the hardware developers. That's just going to happen. The best thing you can do is just try and work around it. Try and get a dev board, wire up a couple of things. Just try and do a bit more homework around what you're doing. So yeah, again, just some lessons learned. We probably should have worked a lot closer with Bob earlier on in the project. We should have been reviewing the layouts. We should have been helping a bit more actively in testing. This again is a bit of a pain because we didn't really have a full software set. This is a very, very new chip. Lastly, just keep things simple. I tried to get a bit smart initially in the project, like lay out all this big framework of stuff. Don't do that. Just mock something up, get it working, and then refactor it later. Otherwise, you'll just tie yourself in knots. That's about all I've got. Thank you very much for listening, and if you've got any questions.
So I understand your point about not using the Arduino IDE, just using make, command line, and so forth. How different are the libraries between the two models? Is it mostly the same shared code? So you mentioned it was not the same, so one was behind the other. So are they different, or?
Effectively, behind the scenes, the Arduino code implemented some of the routines around GPIO and ADC and stuff quite a bit earlier. So they effectively replicate the code. What we've been seeing is some of those replicated or converged code paths have actually been joining as they go along now. So effectively, it's becoming the same code base. It's just Arduino is a bit of an overlay of the IDF. But Arduino was developed before the IDF had those functions. So they did it. They did it themselves.
So if you've written code in the Arduino environment, will it just work in the IDF environment, or the functions that you're calling in the libraries are different?
Just worked.
It works, okay. It's just
what we've done to make that a little bit easier is we've kept the entire environment C++. So even though we're writing C in C++, when we bring C++ code in, we have less boilerplate to bring that in, rather than the inverse, where bringing C++ into a C environment is quite complex. So what we decided to do is, because we just thought there's too much in the Arduino environment to discard, we would just pretty much write a C++ project in C, in the IDF sort of vein, and then wherever needed, just bring in Arduino libraries. Okay. And then we're just using tasks, queues, and semaphores just to try and spread it across the two cores, and also get familiar and illustrate how that can be done. There's a couple of libraries like the wire library and stuff that you really had to have a look at inside the wire library and understand how the buffering works and how it would work with two tasks accessing the same buffers. But overall, it was pretty simple. Like the digital write, digital read, the interrupts, all of that is pretty well very similar in IDF land, but the wrapper, the code is a lot terser. It's a lot simpler for the reader. So that's why we did it. If I was going to do this again, I would probably do exactly the same thing. Just because it made it really easy for us to sort of use code that was already out there, that was already doing really crazy stuff with the hardware, whilst we're getting the body of the work to work, and then replace those components as we went along if we wanted to later.
Understood. Thank you.
Cool.
Okay, we have a couple of minutes for a couple more questions. Anyone else?
Just a question, who has actually worked on embedded projects before? Yeah, there's quite a few people. Awesome. Yeah, it's a very, very big challenge. Like for me, just a totally different world.
Oh yes, question down the back.
I've been in a similar experience where, like, I've worked on a microcontroller project where most of the time I work on much higher levels. In terms of debugging, and actually it was a free RTOS project as well, so I was just wondering if you had any debugging tips and tricks that you came across as you were working on it?
Yeah. So we did, like I very, very quickly started generating errors out of the project, of course. The errors basically come with a stack trace. There is a tool that's provided to effectively extract line numbers in files out of that stack trace. That was invaluable in debugging, at least in the base layer. And later in the project, we actually got access to the newer dev boards which have JTAG on them, but I haven't even looked at that. Whenever I blew something up, I went and hassled Angus and said, hey man, what am I doing wrong here? From that perspective, I was very, very lucky to have access to people who understand a lot of the lower level hardware. If I wasn't in that case, I would probably just ping a GitHub issue and throw the error traces, the ELF file, the binary file and stuff like that up there and just see if someone could help me out. Cool.
For those of us who don't have access to the Angus debugging protocol, is there GDB?
Yes, there is. It's open, what is it? Yeah, OpenOCD support. It's actually quite extensive. They've done a lot of work on that. If you get one of the new boards which has a JTAG on it and stuff like that, it's really, really well set up and well documented. To be honest, I didn't really need that a lot of the times. We normally got enough out of the actual error traces. But yeah, yes, I can understand that.
Okay, well, thank you very much, Mark.
No worries, thank you.